Our node-based dialog system is finally done. However, there still is an extra feature we'll be adding, and that's our custom inspector. Its purpose is quite simple: to make it easier for us to select the in-game starting dialog for that particular game object. We'll be able to filter the dialogues by grouped and ungrouped dialogues, as well as only show starting dialogues or simply show all dialogues. Before we start doing that though, I do have a few graphs prepared to make it easier for us to see if the custom inspector is working as it should. I'll be opening the graphs now, so feel free to copy them and save them, to be able to see it yourself while you are following the tutorial. I'll also be leaving a link to download all the graph scriptable objects as well as container scriptable objects if you prefer that. Do note that it might only work if your dialog system has the same code as mine, or most importantly, classes, variable names, and folder paths. To make this custom inspector, we'll be using Unity's immediate mode GUI system. As for a custom inspector using UI elements, I talk about the reason on why I won't be doing it at the What About UI Elements chapter. Unity's immediate mode GUI is a code-based UI system. This is a separate system from their game-object-oriented UI system, also known as Unity UI or the Canvas system. This code-based UI system is mostly seen being used in custom inspectors or editor windows. So even if you are not going to be using UI elements, this will likely still be useful for you to know. Unity provides us with a few classes that allow us to use this UI system, but we'll talk more about them in a bit. Before we do that, we should first create our custom inspector script. To do that, let's go to our editor dialog system folder and start by creating a new folder to which I'll name inspectors. Inside of this folder, create a new C# script to which I'll name DSInspector. Opening up our script, we'll do the usual removal of the default methods. For our inheritance, we'll be swapping the monobehavior inheritance with editor instead, which will need to import its namespace. I'll make this script be part of the inspector subnamespace. We now have a script inheriting from the editor class, but we are not yet telling Unity that this script should be the custom inspector of a specific monobehavior class. For Unity to know that, we need to give this class an attribute named CustomEditor. When Unity sees that a class has this attribute, it will draw whatever UI we have specified there for every component that CustomInspector is for. Of course, because of that, this attribute requires the type of the class we want to make a custom inspector for. However, we haven't yet created that class. The class we want to make a custom inspector for will be the DSDialogue class, which will be the class that the runtime dialog system you'll develop will be at. That simply means methods that show the current dialog, methods that move on to the next dialog, etc. We will not be doing that part in this tutorial series, as that's really up to how you want your game dialog system to work, as well as whether you want to do it using the old or the new input system. And because there are plenty of tutorials on doing that part out there, I'll leave that for you to explore. Regardless, we still need that class, so back in Unity, go to our non-editor dialog system folder, and in the scripts folder, create a new C# script, which I'll name DSDialogue. Inside, feel free to remove the default methods. We'll leave the inheritance intact as we want to be able to add this class as a GameObject component. I'll also be leaving it in the DS namespace. Our class is created, so we can now pass its type to the CustomEditor attribute. So back to our DSInspector script, above our class, type in the attribute of CustomEditor, and pass in type of DSDialogue. With that done, we need to start creating our dialog variables, as we need to show some UI in the inspector and save its values somewhere. These variables will be separated into two different variable types: the dialog variables, which the DSDialogue script needs, and the inspector variables, which will be used for our inspector only, to make it easier for us to choose the starting dialog. Seeing the final result, we see that our inspector is divided into 4 areas: the dialog container area, the filters area, the dialog group area, and the dialog area. If there was no custom inspector to ease the selection of the starting dialog, our DSDialogue script will simply hold the dialog variable. The reason why is simply because that's the only variable we need to start a dialog chain. That means that every other variable we see in our inspector areas are inspector variables. We now have our variables divided into dialog and inspector variables. However, we'll need every single one of those variables, dialog and inspector, to be created in our DSDialogue script. The reason why we need that is due to how the custom inspector script works. Let's say we were to create a variable of any type in our DSInspector script. In that same script, we would also update it whenever we clicked on a button. In Unity, whenever we click in a game object and we see the component custom inspector, the variable will be created. Then, if we were to click on the button, the variable value will be updated. The problem lies in our variable being created every time we see the custom inspector. This simply means that if we were to deselect the game object and select it again, the variable will get created again and its value will be reset. Because of that, we don't really have a way to store our data in the inspector script and instead need to save it in the DSDialogue script, where we know the data persists. I assume that the reason for this behavior is so that Unity can simply draw the inspector according to the component data, without needing to store a custom inspector for each of the existing components of that type. Of course, Unity does provide us with a way to access that data even though it's in another script. Knowing that, we can start creating our variables. So back in our DSDialogue script, we'll be separating the variables in 2 different areas for now: the dialog scriptable objects and the filters. So create our first private variable of type DSDialogueContainerSO, to which I'll name dialogContainer. Make sure you import the scriptable objects namespace. Then create another private variable of type DSDialogueGroupSO, to which I'll name dialogGroup. As the last scriptable object variable, create a new private DSDialogueSO, to which I'll name dialog. Make sure this last variable is of type DSDialogueSO and not DSDialogue. For our filters, we'll be having the Grouped Dialogues filter and the Starting Dialogues Only filter. The Grouped Dialogues filter will allow us to filter through grouped dialogues when it's set to true, or ungrouped dialogues when it's set to false. The Starting Dialogues Only filter will only show starting dialogues if it's set to true, which simply means that the dialogue is starting dialogue property is also set to true, or all dialogues if it's set to false. So type in private bool grouped dialogues, and then private bool starting dialogues only. To make sure these variables show in the inspector and to make sure we can get them in our inspector script, add the serialized field attribute to each of the variables. Our variables are done, so we can go back to our DSInspector script. In here, we need a place to be able to draw our UI. We can do it in a method named OnInspectorGUI, which we need to override. To do that, simply press Alt-Enter in Visual Studio and select Generate Overrides. In there, press Deselect All and then tick the OnInspectorGUI option. When that's done, simply press OK to override the method. Feel free to remove the base method call. Anything we add in here will be shown in the component custom inspector. One thing to note about this method is that it gets called multiple times while the inspector is active, which will turn out to be useful for us as it redraws the UI, which we'll need it to later on. We can now start drawing our UI here, but we are currently facing a problem. If our variables are in our DSDialogue script, how do we get to access them? We can easily do that by using the provided Serialized object editor variable together with its findProperty method. Simply put, the Serialized object variable holds the object that's currently being inspected, which is our dialog object. Its findProperty method allows us to get the data of a variable in that dialog object, which we can then store in a variable of type Serialized property. The difference here is that we can have this variable be in our inspector script, as every time we enable the inspector, we'll be assigning a value to it using the findProperty method, and because of that, we don't really need to worry about it resetting, as it's always getting the dialog object variable data. We'll go into a bit more detail on the Serialized object and Serialized property later on. With that in mind, we can start creating our Serialized property variables. Of course, we need one of these properties per variable, so we'll also divide them into the same areas: the dialog scriptable objects and the filters. For our scriptable objects, type in private serialized property and I'll name it dialog container property. I'll simply add property at the end of the DSDialogue variable names. Next, type in private serialized property dialog group property. And for our last scriptable object, type in private serialized property dialog property. For our filters, type in private serialized property grouped dialogues property and private serialized property starting dialogues only property. We have all of our serialized properties created, so we shall now initialize them to all the DSDialogue variables data, which we'll do using the findProperty method. To do that, we'll do it in the onEnable method, so that we call it once every time we open the CustomEditor. So type in onEnable and accept the autocomplete. Initialize the first property by typing in dialog container property equals to serialized object dot find property. This method requires an argument, which is simply the name of the variable in our DSDialogue script, so that it can bind this property to the correct data. So simply pass in dialog container. Do the same for the rest of our properties. With our properties initialized, we can finally start drawing our UI. Before we do that though, we'll go through what the final result will look like, as well as what are we going to use to draw it. Although we already have looked at what the final result with the dialog selected should look like, we haven't really seen how it looks until we get there. Let's start by taking a look at how our inspector looks like when we haven't yet selected a dialog container. When that's happening, a message should be showing saying that we should select the dialog container if we want the rest of our custom inspector to show up. There should also be a warning message saying that we should select the dialog for this component to work properly, which will always show until we select the dialog. Both of these will end up kind of fixing some small bugs that will happen if we didn't have them. Those bugs are fixable, but will require more code in our part or just a small update. I will of course be explaining later on what those little bugs are whenever we get to them, in case you prefer not to have the custom inspector be this way. Then whenever we select the dialog container, our filters will show up. What shows next to the filters depends on what filters are selected and the contents of the container. If we tick the Group Dialogues filter, there are two possible outcomes. If the container has groups, then the groups area will show up with the corresponding property. If the container does not have groups, then a message will show up saying that this container holds no groups. Before we head to the next filter, let's first talk about the dialogues area. If we are filtering by grouped dialogues and the currently selected group does have dialogues, we'll show the dialogues area and we'll be able to select a dialogue. If the group does not have dialogues, then a message will show up saying there are no dialogues in the current group. If we were seeing ungrouped dialogues, then if the container has ungrouped dialogues, the dialog area will show up and we will be able to select a dialog. If the container does not have ungrouped dialogues, then a message will show up saying there are no ungrouped dialogues in this container. If we were to select the second filter, regardless of what the first filter was, if there are starting dialogues in the current scope, then the dialogues area will look the same, but with possible less dialogues to choose from. If there are no starting dialogues in the current scope, grouped or ungrouped dialogues, then the same message as before will show, but with another starting word to remind the user that there are no starting dialogues, but there can possibly be non-starting dialogues. Of course, when we do have a dialog selected, no message should be showing anymore. If you are wondering what's the reason we have the dialog group and dialog dropdowns, that's simply that I couldn't find a way to only show the current container groups or dialogs in the normal asset picker, as it can only filter by their type and not by where they are located. So we'll instead select our scriptable objects through a dropdown menu. And that's basically what our custom inspector will look like. With our custom inspector structure explained, we can finally start drawing it. Of course, we should first understand what are we going to use to draw our UI. Unity provides us with a few classes that use the immediate mode GUI system to draw the UI for us. Those classes are the GUI class and the editor GUI class. The GUI class can be used both for runtime UI and editor UI, but ended up, I believe, becoming deprecated for runtime UI in favor of the current Unity UI system. The editor GUI class can be used for the editor only and might have some UI differences compared to the GUI class. It is also possible that one class has different UI options. These classes, however, offer fixed layouts. This means that you will need to set the positions and so on of your elements yourself. This is good if you want to have more control on how your inspector looks like. However, we don't really want to do that ourselves for the inspector and want it to just automatically look like a normal inspector. Thankfully, both of these classes have another class that basically wraps them, but make it so that their layouts are automatic. Those classes are the GUI layout class and the editor GUI layout class. For our custom inspector, we'll only be using the editor GUI layout class. Of course, you are free to use both of them at the same time if you want to. We now know what we need to do, so go back to our DSInspector script. We'll actually start by drawing the base of our UI without the message boxes that we have seen, and then start drawing those step by step as we go through the custom inspector features. So in our OnInspectorGUI method, start by calling in a new method we'll be creating named DrawDialogueContainerArea. I'll place this method inside of a new region named drawMethods. We'll be drawing our dialog container area here. There are two elements we need to draw, the header label and the dialog container property. Let's start with our header. To draw it, we'll be using the label field method. So type in editor GUI layout.label field, and for the text of this label, we'll pass in dialog container. However, as it stands, this label won't really look like an header, as its text isn't bold. To make this label text bold, we can pass in a second argument of type editor styles, which has several pre-made editor styles. If we type in a dot, we can see the many styles it has. If we search for a label, we can see that there are a few pre-made label styles as well. We will select the bold label style. Our header is not looking as it should, so we should draw our property next. To do that, type in editor GUI layout.property field. There's also the Object Field method for the Asset Picker UI, in which you can select what type of asset you want to pick. But the property field already does that automatically for us and even checks what type of UI should be drawn depending on the variable type. The property field automatically adds the field label for us as well. For the property field argument, it requires the serialized property that we want to draw, so simply pass in dialog container property. We do not need to add anything anywhere for our UI to be drawn, as Unity automatically does that for us. So with that done, our dialog container area is now being drawn nicely. The next area we'll be drawing will be our filters area. So in our OnInspectorGUI method, calling a new method will create, which I'll name DrawFilters area. I'll place it in the draw methods region. In here, let's start by drawing our header by typing in editor.GUI layout .label field and pass in filters for the text and editorstyles.boldLabel for the label style. Then draw the properties by typing in editor.GUI layout .property field grouped dialogues property and editor.GUI layout .property field starting dialogues only property. That's all we need for our filters area. Next, let's draw our dialog group area. So in our OnInspectorGUI method, calling a new method will create named DrawDialogGroup area. I'll place it in the draw methods region. For this one, feel free to copy the code we have in our dialog container area method and paste it here. Then simply swap the header text to be dialog group and the property field to be dialog group property instead. There is another element we'll be adding though, and that's the dropdown element you see in the inspector. Unity actually calls this dropdown a popup. So just above our property field, type in editor.GUI layout.popup. In our case, we'll be needing to pass in 3 arguments: the field label, the list of the popup options, and the currently selected option index. Start by passing in our label by typing in dialog group. Our second argument is the selected option index, but we currently have no way of knowing it. If we were to pass in 0 right now, when selecting a pop-up option, it will always stay with the first element selected, because the OnInspectorGUI is being called multiple times. And because it's redrawing the UI, it will see that the selected index is 0, therefore not changing to the one we chose. Thankfully, the method does return the current selected index, which updates when we select a new option, so we can simply save it somewhere and then pass it in as a second argument, so that the next time it is redrawn, it will be the same index as the last selected option. Of course, we know that the variable in our inspector will reset every time we open it, so saving the currently selected index in here wouldn't work, as it will be simply reset to 0 or any other default value we could give it whenever we open the custom inspector. For that reason, we'll create a variable in our dialog script that holds the currently selected index. So in our DSDialogue script, add a new area to the variables that I'll name indexes. For the variables, we'll need one index variable for each popup, so one for our dialog group and another one for our dialog. So type in private int selected dialog group index and private int selected dialog index. Make sure both of these variables have the serialized field attribute. With that done, go back to the DSInspector script and we'll be creating our properties. So add in a new area for our indexes and then create the properties by typing in private serialized property selected dialog group index property and private serialized property selected dialog index property. then initialize them in our onEnable method. When that's done, go back to our DrawDialogueGroupArea method, and we can now pass in the SelectedDialogueGroupIndex property as a second argument of the popup. However, we need an integer value for this parameter. To get the actual value of our property, we can simply type in dot, and we'll see multiple value variables for each type. We want to choose the int value variable. We are now passing in the actual integer value of that property. So we can now pass in our third argument, a string array of options. In here we'll be having the names of the existing groups. However, we'll actually do that later, so for now we can simply pass in a new string array. All of our arguments are in, but remember that if we leave things as they are, our selected index value will never change and we'll have the same problem. This is because we need to set its value to the returned popup value. So before our popup, in the same line, type in SelectedDialogueGroupIndexProperty.intValue equals to the popup returned value. We are now passing in the old selected index value and then assigning the new selected index value to the property, so that it is updated in the next redraw. With our dialog group area done, it's time for us to draw our last area, the dialog area. So in our OnInspectorGUI method, call in a new method we'll create named DrawDialogueArea. I'll place it in the draw method's region. This area will be pretty much the same as our dialog group area, so feel free to copy its code and paste it here. Then simply remove the group part of all the variables and texts. And that's our dialog area being drawn as well. With that done, all of our areas are being drawn. However, they are currently standing too close to each other, so I would like to give it some spacing between them so that the inspector looks a bit better. Thankfully, that's pretty easy to do using the EditorGUI layout space method. We'll be adding it at the end of the first 3 areas, as the last one has nothing under it, so it needs no spacing there. So in our DrawDialogContainerArea method, at the end, simply type in EditorGUI layout.space. And for the amount of space we want to give, I'll pass in 4. Feel free to try it out and pass in whatever amount you like. Then we'll copy this line and simply paste it both in our DrawFiltersArea method and in our DrawDialogGroupArea method as well. If we save and go to Unity, we can't yet see our UI being drawn, because we don't really have an object with it. So create a new empty object in the scene and I'll name it Dialog. And then simply add the DSDialogue component to it. We shall now be able to see our UI. If you are having a weird bug here where it says the reference of the property is null, I've copied the DSDialogue script code, deleted the file and recreated it in the same place, pasting in the copied code, and it no longer gave the error. So if you currently find yourself with that bug, that might fix it. Another possible fix is to make sure you have the serialized field attribute in the variables and their names are typed in correctly in the findProperty method. However, we have a problem. If we try to update the field value, let's for example click in one of our filter toggles, their values don't really get updated. To better understand the reason why this is happening, we'll talk about the serialized object and the serialized properties in a little bit more detail. The serialized object is simply a representation of the data of our class, which in this case is the DSDialogue class, as that's the class this CustomInspector is for. Whenever we select a game object with this component, the serialized object variable of that component CustomInspector becomes a representation of that specific component data. Because that object is representing that component class data, it means it also has a way to understand what variables that class has and a way to get their values. That is what the findProperty method is for, to find a serialized property. Property is simply the word Unity gives to a field or a variable. Because this method tries to find a serialized property, it means that for it to be able to find it, our property or variable needs to be serialized. That's the second reason why we have added the serialized field attribute to our DSDialogue class variables. The serialized property is simply a class that is able to hold data related to a property, like its type, so that it can then set the correct value in the correct variable and return it when we need it. That's how it knows the value of the field whenever we type in something like int value, like we did in our indexes. Now, for the reason why our values aren't being updated. These variables hold the representation of our data. Because it is a representation, when we update the properties, their values aren't really being synchronized with the actual DSDialogue variables. So what we need to do once we update the property values, which represents our data, is to simply make sure we apply those changes, so that Unity synchronizes the DSDialogue variables values to hold these new values, meaning that the next time the UI is drawn, they will now have the UI updated to represent those new values. We can do that by using the serialized object ApplyModifiedProperties method. To make sure we get an updated data representation, just in case some property was modified elsewhere, we need to call in the serialized object update method. Therefore, the update method shall be called at the beginning of the OnInspectorGUI method, to make sure we are going to be drawing our UI with the correct data. And our ApplyModifiedProperties method shall be called at the end, after we draw all of our UI and possibly change the data of one of the elements. Now that we know what's happening, we can easily fix it by going back to our DSInspector script and in our OnInspectorGUI method, type in at the start of the method serializedObject.update. And then at the end of the method, type in serializedObject.applyModifiedProperties. If we save and go back to Unity, our property values shall now be updating. We can now draw the rest of our custom inspector. However, we'll do one last thing before we do that. When we finish up our custom inspector, it is likely that we'll want to add new properties to our dialog script. That simply means that we'll need to add the UI here as well. We can do that either using the DrawDefaultInspector or DrawPropertiesExcluding methods. But in case we want to do something like our current UI, we'll need to repeat the already existing code. What we'll be doing is to simply allow us to call something like DrawHeader without needing to specify ourselves the label styles, or simply call in serializedPropertyVariable.drawPropertyField to draw the property in the inspector. To be able to do that, we'll be creating our own InspectorUtility script. So in our editor dialog system utilities folder, create a new C# script to which I'll name DSInspectorUtility. Inside, feel free to remove the default methods together with the monobehavior inheritance. I'll make it part of the utility subnamespace. I'll also make this class be static. We'll be creating a method for our headers, our properties, our pop-ups, and our spaces. The last one isn't really necessary, but just makes it so we call the inspector utility like the rest of our code. Let's start with the header method by typing in public static void DrawHeader. And as the first argument, we'll need to pass in a string to which I'll name label. Inside, call in editorGUILayout.labelField. Make sure you import the necessary namespace. Then pass in label as the first argument and editorStyles.boldLabel as the second one. Our DrawHeader method is now done. So next, let's do one for our properties. To do that, type in public static void and I'll name it DrawPropertyField. We'll make it so we can call this method through the variable itself. So pass in a new parameter saying this serialized property serialized property. We can now simply do our serialized property.drawPropertyField. Inside, call in editorGUILayout.PropertyField. and pass in Serialized property as an argument. When that's done, create the popup method by typing in public static void draw popup. As parameters, we'll have a string label, a serialized property, selected index property, and a string array of options. The second parameter is just so we can send in the property without needing to type in the int value part every time we call this method. Inside, call in editorGUILayout.popup and pass in label, selected index property, .intValue, and options. Of course, make sure to return this line and update the draw method return time to be int instead, as the popup needs to return the new selected index. If you do prefer to pass in the int value instead as the selected index, that's fine as well. Simply copy the draw popup method and paste it in again, and then swap serialized property with int and name it selected index instead. Then remove the property.intValue from the second popup method argument. We can now call this method the way we prefer. All that's left is our space method, so type in public static void draw space and pass in int amount as a parameter. I'll default its value to 4. Inside, simply call in editorGUILayout.space and pass in amount as the argument. That's all of our methods done, so we now simply need to update our inspector script to use them. So, back to our DSInspector script, start by importing the utilities namespace. Then we'll start updating our method calls. Start by updating every label field to call in the DSInspectorUtility.DrawHeader method instead. When that's done, let's swap our properties to use the new drawPropertyField method. Remember that we can just type in dialogContainerProperty.drawPropertyField because of the this keyword. Do the same for the rest of the properties. Next, swap our space methods with our drawSpace method. We don't need to send in 4 because it is already defaulted to that value. When that's done, swap our popup methods with the drawPopup method instead. I'll be using the method overload that sends in the serialized property. Our custom inspector is now using all of our utility methods. We won't be doing one to initialize our properties because they don't seem to be of reference type, and passing in ref, out and in did not seem to work either, so we'll leave them as is. With that out of the way, we'll start drawing the remaining elements of our inspector. This time though, we'll draw the UI in the order of our property selection, and finish the rest of the features as we do that. The first thing we'll be drawing is a message that shows up when no dialog containers are selected. To do that, go to our OnInspectorGUI method, and in here, we'll simply need to check if the dialog container property value is null, and if it is, draw the message and return from the method, as we don't want to keep on drawing. So, just under our drawDialoguesContainerArea method call, type in if dialogContainerProperty dot offset reference value equals to null. We get the offset reference value variable here because our property allows us to select offsets using the asset picker. Inside of the if statement, we can draw the box using the helpBox method. So type in editor.GUI layout.helpBox, and as a text we'll pass in select a dialog container to see the rest of the inspector. Then as a second argument we can pass in what type of box it will be, which really only updates the icon that appears before the text. I'll pass in messageType.info. As a third argument is simply whether we want the box to be the width of the inspector or simply the width of the property field, label width excluded. Because I want it to be wide, I'll actually not pass in anything, as it defaults to true, which is exactly what we want. Of course, let's also add this method as an utility method. So in our DSInspectorUtility script, create a new public static void method, which I'll name DrawHelpBox. I'll pass in string message as the first parameter, message type as a second, which I'll default to messageType.info, and then boolwide as a third one, to which I'll default to true. Inside, simply call in editor.GUI layout.helpBox and pass in the three parameters as arguments. Back to our DSInspector script, swap the current helpBox method to use the DrawHelpBox method instead. With our helpBox now being shown, we can stop drawing the rest of our UI. To do that, we can simply type in return at the end to return from the OnInspectorGUI method. Of course, because we are returning here, our ApplyModifiedProperties method call at the bottom of the method will not be called. So we need to make sure we call it before returning as well. So type in Serialized object.ApplyModifiedProperties. Because we'll be doing this several times, one for each helpBox, we'll just select this code without the return part and extract it to a method. I'll name this method StopDrawing. I'll place it in the draw methods region. In here, I'll add in a parameter of type string, which I'll name reason. This is simply the reason why we want to stop drawing, which will be the helpBox message. Then copy or cut the text in the DrawHelpBox method and swap it with reason instead. Once that's done, make sure that in our method call we pass in the text we've just copied. If we save and go back to Unity, if we do not select a dialog container, we shall see there's an helpBox showing with no other UI under it. If we do select a container, the rest of our UI should show up. With that done, we'll now make it so our dialog groups only show up if the grouped dialogues filter is on, and also show an helpBox if there are no groups in the current container. To do that, back in our DSInspector script, in the OnInspectorGUI method, type in just above our DrawDialogues group area method call, if GroupeDialoguesProperty.bool_value. If this is true, then we can draw our dialog group area, so simply move the DrawDialogueGroupArea method call inside. In here, we'll be getting the dialog group names in this container so that we can pass them in as the pop-up options. However, if this list of group names is empty, we can simply throw in the info message and stop drawing, as that means there are no dialog groups in the current container. Of course, we don't yet have a way to get the names of the groups, so we'll have to create that first. To do that, let's go to our DSDialogueContainerSO script. In here, we'll create a new method that gets us the name of the groups. So type in public list of strings, and I'll name it GetDialogueNames. Inside, we'll simply iterate through the dialog groups and add their names to a list that we'll need to return, as we'll need it in our inspector script. So create that list by typing in list of strings, and I'll name it DialogueGroupNames. Don't forget to initialize it. Then iterate through the dialog groups dictionary keys, which are all of the container groups, by typing in, for each, DSDialogueGroupSO, dialog group, in DialogueGroups.keys. Inside, simply add the dialog group name to the list by typing in DialogueGroupNames.add DialogGroup.groupName. Once that's done, simply return the list. We are now able to get our group names through our dialog container scriptable object. So go back to our DSInspector script and we'll be needing to call the method we have just created. However, we don't really have a reference to our dialog container scriptable object, so we have no way of calling in the method we have just created. Thankfully, that's quite easy to get, as we just need to cast the dialog container property value to the corresponding type. So above, just after we draw our dialog container, create a new variable of type DSDialogueContainerSO and import its namespace. I'll name the variable dialog container. Then assign to it dialog container property .object reference value and cast the result. Note that it's important for you to do this after drawing the container property. I'll be explaining why later. When that's done, back in our group filter if statement, create a new list of strings to which I'll name DialogueGroupNames. Then assign to it DialogContainer.getDialogueGroupNames. Now that we have the reference to our container, we can also swap it in our if statement to check if this variable is null instead. With our list here, we can stop drawing our inspector and show the info message if the list is empty. So type in if DialogueGroupNames.count == 0. And inside call in StopDrawing and pass in there are no dialog groups in this dialog container as the reason why we have stopped drawing. Of course, don't forget to return at the end. If our list is not empty though, we'll show our dialog groups. In there, we need to show every group name as a pop-up option, so that we can select the group we desire. To do that, pass in our dialog group names list to the DrawDialogGroup area method. If you are in Visual Studio, press Alt-Enter and select Add Parameter to Method. This simply automatically adds the parameter to the method for us. Then, in our DrawDialogGroup area method, we'll swap the empty string array in the drawPopup method to be DialogGroupNames instead. Of course, don't forget that the method requires an array and we have passed in a list. So we need to convert it to an array by typing in .toArray. If we save and go back to Unity, a dialog container with no groups should show the help box. If we, however, select a dialog container with groups, the dialog group area should show instead, now with the list of the group names in the pop-up. We are also able to select the option we desire in the pop-up. However, even though we are selecting the group we want, we aren't really setting the property to be this group scriptable object. To do that, we'll need to get the reference to the selected group by loading its asset. Thankfully, we already have the name of the group we want to load in the pop-up option, and we also have the dialog container name to know in what folder the group is on. So we can use both of those to load our group asset. The only thing we need now is to have a way to load that asset. If you have done the save and load systems, we have a DSIOUtility that holds a method for that purpose. Of course, back then we haven't made them public, but we'll do that now, as they are methods that can be called in other places. So, go to our DSIOUtility script, and in our utility methods region, set every method except the clone method to be public. Then back to our DSInspector script, in our OnInspectorGUI method, pass in the dialog container variable to the DrawDialogGroupArray method to add as a new parameter. This is simply to be able to load the group asset at the correct path. In our DrawDialogGroupArray method, just after we draw the pop-up, create a new string variable to which I'll name SelectedDialogueGroupName. Then assign to it DialogueGroupNames at the index of SelectedDialogueGroupIndexProperty.intValue. Then with this name we can load the asset we want, so create a new variable of type DSDialogueGroupSO to which I'll name SelectedDialogueGroup and load the asset by typing in DSIOUtility.loadAsset of type DSDialogueGroupSO, and for the path the asset is in, we'll pass in an interpolated string saying assets at dialogue_system at dialogues at between curly brackets dialog container dot filename at groups at between curly brackets as well selected dialog group name. This path leads us to the group folder, so now we simply need to load its asset by passing in selected dialog group name as a second argument. With this, we are now loading in our asset. Then set the group property to be this value by typing in dialog group property dot offset reference value equals to selected dialog group. If you are wondering why we need this asset, we'll use it to get our grouped dialogues. If we now save and go back to Unity, selecting a group in the pop-up should load the respective asset. However, we have a few problems. They are simply regarding the selected index whenever the list of options is updated. This can happen when we select a new dialog container, tick and untick filters, or update the graph. Let's say we chose the last group in the pop-up options in the full container. This group has the index of 2. If we were to select a new dialog container and that dialog container didn't have enough groups for one of them to be in the index of 2, then Unity will throw an error as it cannot find a member in its names array at the index of 2. The same happens when we select certain filters or update the graph, as we might have saved the graph with less elements than before. Another problem with updating the graphs is that we might remove an element whose index was lesser than the currently selected index, which will mean the names list will go down one element, so the currently selected index will be a name that was one index up before. Because of that, we need to make sure we reset our indexes to 0 again, or if the old name is now different than the name at the old index, search for the correct old name index in the names list. Of course, we'll also need to reset our dialog index for the same reason. Now, I've said before that the help boxes helped us out fixing two small bugs. One of them is right here. Whenever we set the index to be 0, if our array turns out to be empty, then the index of 0 is also invalid, as that simply means the first element. Thankfully, due to our help box if statement, this will never throw an error. The reason why is simply because if the list is empty, we'll stop drawing and return from the OnInspectorGUI method, meaning we'll never get to our pop-up line. So let's fix this problem by going back to our DSInspector script, and in our DrawDialogueGroupArray method, we'll need to get the old selected index to be able to know if the old name is different than the current names list element at the old index. We can do that pretty easily by creating a new variable just before we draw our pop-up. So before drawing our pop-up, type in int old selected dialog group index equals to selected dialog group index property dot int value. We now have a reference to the old selected index. Now, this might be a bit confusing. If we are applying the changes at the end of the method, how is it possible to get the old index when the UI is being redrawn? Shouldn't the index value be updated by now? Well, I've tested it out myself, and apparently those changes that we applied are only applied when we draw the element again. Until then, the values of the element will remain their old values. This was easily tested in the final result of the custom inspector. I have a dialog selected here, and in the onEnable method I have a debug log printing out what's the currently selected dialog. If we now were to update the dialog container to none, we shall see the info and warning messages and no dialog should be selected. However, if we do get to print our onEnable debug log again, we can see that the old dialog is still selected. This is because we haven't yet drawn the property field again, so the values remain unchanged, even though we have applied the changes. This is the second bug that I've talked about, that the warning message helps out mitigating. If the user does not select a starting dialog, it is possible that the dialog variable will have a value in it, even though it shouldn't. Of course, this will be easily fixable by simply setting our property value to null whenever we stop drawing. However, this will also make it required for us to get the old dialog group and dialog through a different way, which will probably be an extra variable in our DSDialogue script. Because I personally know I should always choose a dialog, I'll leave it as is. Feel free to try to do it the other way if you prefer. With that explained, let's now reset our group index. To do that, we need our old dialog group as well, so before our pop-up simply type in DSDialogueGroupSO old dialog group equals to dialog group property dot object reference value and cast the result. Then if the old dialog group was null, we can simply reset the index, as that means no group was selected, so we don't really care about searching for the name. So type in if old dialog group equals null, and inside type in selected dialog group index property dot int value equals to 0. Else, if the group was not null, we want to check if the old name is different than the currently selected name. So type in if old dialog group dot group name different than dialog group names at the old selected dialog group index. However, we need to remind ourselves that the old selected dialog group index can be an index higher than the current maximum index on the names list, and if it is, then it's the same as saying that the names are different. So type in, just before the current condition, old selected dialog group index greater than dialog group names dot count -1 because indexes start at 0, or the other condition. Make sure to place this condition before the other so that the second one doesn't throw an index out of bounds error. If one of these is true, we can update the currently selected index. Then inside we'll need to check if the old name exists in the list, and if it does, we can set the current index to the index of that element. If it can find it, we can just set the index to be 0 instead. So type in if dialog group names dot contains old dialog group dot group name, and if it does, we type in selected dialog group index property dot int value equals to dialog group names dot index of old dialog group dot group name. Otherwise, or else, we can simply set the selected dialog group index property dot int value to be 0. I'll now select these if statements and extract them to a new method to which I'll name updateIndex on dialog group update. I'll place this method in a new region named indexMethods. However, we want to be able to reuse this method in our dialog area as well, as it faces the same problem, so we'll be updating it to be reusable. To do that, first swap the DSDialogueGroupSO parameter to be bool is old property null instead. When that's done, swap the first if statement to use this variable and if that's true, simply return from the method, which makes it so we can remove our else statement. Of course, this made it so we don't have the group and can't get its name because of it, so create another parameter before our bool parameter of type string, which I'll name old property name. Then swap it with our old DialogueGroup.groupName usage. When that's done, we'll rename our DialogueGroupNames parameter to be option names instead, and the oldSelected dialog group index to oldSelected property index as well. The only thing left to do is to update the correct index property, so add a new parameter after our string list of type Serialized property, to which I'll name index property. Then swap the selected dialog group index property with index property instead. This works even though serialized properties aren't by reference, because the property we pass in is a global variable in this script. One last thing we'll do is to add the conditions as variables. So above our if statement, type in bool old index is out of bounds of names list count equals to old selected property index greater than option names.count minus 1, and then bool old name is different than selected name equals to old index is out of bounds of names list count, or old property name different than option names at the old selected property index. When that's done, swap the if statement condition with old name is different than selected name instead. I'll also update method name to be update index on names list update. Back when we call the method, start by calling it with the correct name. Then pass in selected dialog group index property as the second argument. And for the last two, we'll be creating two variables, so above type in bool is old dialog group null equals to old dialog group equals null, and then string old dialog group name equals to is old dialog group null, and if it is, then we set it to an empty string, otherwise we set it to old dialog group.groupName. We aren't using the null conditional operator here because apparently you shouldn't be using those in Unity objects, as what's null here is decided by Unity and it might be something we didn't expect. Then pass these two variables as the last two arguments, removing the old dialog group argument. If we save and go back to Unity, our pop-ups shall now work correctly no matter what we update. All that's left now is our dialog area. We'll show it in two different situations. When the grouped dialogues filter is set to true, which will show the dialogues of the selected group, or when the grouped dialogues filter is set to false, which will show the container ungrouped dialogues. The differences between these situations are the method we call in to get the dialog names, as one gets the grouped dialog names and the other one gets the ungrouped dialog names, the path of where we need to load the asset from, as one is inside of the groups folder and the other one is inside of the global folder, and the message we want to show if there are no dialogues, as in one we need to say there are no dialogues in the group, while in the other one we need to say there are no ungrouped dialogues in the container. This means that we'll need to create one variable for each of these and set them accordingly depending on the filter value. which we can do in this if statement for the grouped dialog situation and in an else statement for the ungrouped dialog situation. So in our DSInspector script, in the OnInspectorGUI method, above our grouped dialogs filter if statement, create a new list of strings to which I'll name dialog names. We don't really need to initialize it here because we'll be setting the variable in both of our if and our else statements. Then create a new string to which I'll name dialog folder path. And we'll be initializing this variable with the path as equal for both situations, which is until the container parent folder. So initialize it with an interpolated string and type in assets @dialog system @dialogs between curly brackets dialog container .filename. Next, we want a string variable for our dialog info message, which will be the message that will show if no dialogues can be found for that specific situation. When that's done, we'll set the values for when our grouped dialogs filter is on. So we'll be setting the variables inside of the if statement. The first one we want to get is a list of grouped dialog names, but we don't really have a way to get them. But like we did for our groups, we'll create a method that returns them in our dialog container. So go to our DSDialogue container SO and create a new public method that returns a list of strings to which I'll name GetGroupedDialogueNames. We'll be getting the dialogues of a specific group, which we can do through the dialog groups dictionary. So we'll pass in the group as a parameter. So type in DSDialogue group SO dialog group. Inside, start by getting the list of the grouped dialogues by creating a variable of type list of DSDialogue SO, to which I'll name grouped dialogues. Then assign to it dialog groups at the key of dialog group, which simply returns a list of dialogues present in this group. Then create a new list of strings, to which I'll name GroupedDialogueNames and initialize it. Next, we'll iterate through the grouped dialogues list by typing in, for each, DSDialogue SO, grouped dialogue, in grouped dialogues. And inside, we'll add this dialog name to the list by typing in GroupedDialogueNames.have and pass in GroupedDialogue.dialogueName. When that's done, simply return the list at the end. We cannot set our dialog names list, so back to our DSInspector script, just after we draw our dialog group area, type in dialog names equals to dialog container dot get grouped dialog names. We need to pass in the group the dialogues belong to here, so above type in DSDialogue group SO and I'll name it dialog group and assign to it dialog group property .object reference value and cast the result. Then pass this variable into the GetGroupedDialogueNames method. For our dialog folder path, we'll be using the current string and concatenate the rest of the path. So type in dialog folder path plus equals interpolated string at groups at between curly brackets dialog group dot group name at dialogues. For our dialog info message, we'll pass in the string of there are no dialogues in this dialog group. With that done, all of our variables are set up for when we have our grouped dialogues filter set to true. Of course, we shall now do the situation where the filter is off, so start by typing in else. In here, we'll start by setting our dialog names list, which we of course need to create a method that gets us the names. So go back to our DSDialogue container SO script and in here create a new public method that returns a list of strings. And I'll name it GetUngroupedDialogueNames. Inside we'll do what we did for the other methods. So type in list of strings and grouped dialog names and initialize it. Then iterate to the ungrouped dialogues list by typing in for each DSDialogue SO and grouped dialog in ungrouped dialogues. Inside, add the name to the list by typing in UngroupedDialogueNames.add and pass in UngroupedDialogue.dialogueName. At the end, simply return the list. When that's done, go back to the DSInspector script and inside of the else statement type in DialogueNames equals to dialog container dot GetUngroupedDialogueNames. For the folder path, type in dialog folder path plus equals @global@dialogues. For the info message, type in dialog info message equals to there are no ungrouped dialogues in this dialog container. All of our variables are now set for both of the situations. Before we pass the necessary info to our DrawDialogueArray method though, we'll stop drawing if the dialog names list is empty. So after our if-else statement type in if dialognames.count equals 0. We can then call in StopDrawing with the reason of dialog info message. Of course, don't forget to return at the end. That's it for the situation where there are no dialog names, so we'll now do the situation where there are dialog names in the list. So start by passing in two arguments for our DrawDialogueArray method, dialog names, and then dialog folder path. Then press Alt-Enter and choose to add them as parameters to the method. When that's done, inside of our DrawDialogueArray method, update the empty string array to be dialog names instead. Don't forget to add .toArray as well. Once we have our popup with its options, we can load the selected asset and set the property to use it. So first, create a new string to which I'll name SelectedDialogueName and assign to it dialog names at the index of selected dialog index property .int value. Then create a new variable of type DSDialogueSO to which I'll name SelectedDialog and load the asset by typing in DSIOUtility.loadAsset of type DSDialogueSO and pass in dialog folder path for the path and selected dialog name as the asset name. Once we have our loaded dialog, we can set the property value to hold this value by typing in dialog property.objectReferenceValue equals to selected dialog. Our dialog property is now being set correctly. We also have no fields that we can select depending on the chosen dialog, so we don't really need to reset any index. However, we do also need to update our index whenever an update to the graph, container or filters happens. To do that, just before we draw our popup, type in int oldSelectedDialogIndex equals to SelectedDialogIndexProperty.intValue, and also create the old dialog by typing in DSDialogueSO oldDialog equals to dialogProperty.objectReferenceValue, casting the result. Then copy both the bool and the string variables from the dialog group area and paste them here. When that's done, simply remove the group part of the names and swap the group name with dialog name instead. When that's done, call in updateIndexOnNamesListUpdate and pass in dialog names, selected dialog index property, old selected dialog index, old dialog name, and is old dialog null. That's all we need for our index update. Do note that updating the element names in the graph will make it so the index is reset or swapped to the element whose name is equal to the old selected name, even if it's not the same element. But I'm fine with that. We are almost done with our custom inspector, but we still need to do 3 small features. Filtering the dialogs by starting dialogs only, disabling our property fields, and adding the warning help box. Let's start by filtering our dialogs. Thankfully, that's quite a simple thing to do. To do it, let's head to our DSDialogue container.so script again, and we'll need to update both of our DialogueNames methods. I'll start with the GetGroupedDialogueNames method, and then just copy everything to the GetUngroupedDialogueNames method. So pass in a parameter of type bool, to which I'll name starting dialogues only. In here, we'll filter the dialogues out by adding the following condition. If the parameter we pass in is true, then we'll only want to add the dialogue name to the list if the current dialogue is starting dialogue property is set to true. That means that if the parameter is true and this variable is not, we want to continue to the next element. If the pass-in parameter is false, this condition code will not run and the loop will run as it did before, adding every dialogue name to the list. So in the for each loop, type in if starting dialogues only and not grouped dialog.isStartingDialogue, and inside simply continue to the next element. That's all we need to do, so when you are done doing that, copy this whole if statement and pass it into our GetUngroupedDialogueNames method for each loop as well. Of course, don't forget to copy the bool parameter as well. Then swap the grouped dialog variable with ungrouped dialog instead. Both of our methods are now able to filter by starting dialogues only. So back to our DSInspector script, after we draw our filters, create a new variable of type bool, to which I'll name current starting dialogues only filter, and set it to be starting dialogues only property .bool value. Then we simply pass this variable to both methods. That's done, but I'll also make it so our info message gets the starting word added to it before the dialogue's word in case the filter is set to true, just so the user knows it could not find starting dialogues but can still possibly find non-starting dialogues. To do that, concatenate a string after the no word and type in between parentheses current starting dialogues only filter question mark space starting, otherwise empty string. This is called a ternary condition. If the condition is true, then the first statement will run and it will concatenate starting to the string. If the condition is false, then the second statement will run and it will concatenate an empty string to the string. Copy this concatenation and paste it in the other dialog info message text assignment as well. Saving and going back to Unity, we shall now be able to filter the dialogues by starting dialogues only or all dialogues. If there are no starting dialogues, the info message will also be updated to reflect that. The next thing we need to do is to disable our dialog group and dialog property fields, just to make sure we do not accidentally select a random asset from it and break the inspector. To do that, we'll be using two EditorGUI methods named beginDisabledGroup and then DisabledGroup. Let's create this method in our inspector utility right away, so go to our DSInspectorUtility script and in here, create a new public method above all the others, to which I'll name drawDisabledFields. Inside, type in EditorGUI.beginDisabledGroup and pass in true as the argument, simply to say we want to disable what's going to be in between the two methods. Then at the end type in EditorGUI.endDisabledGroup. Any element between these two lines will be disabled. Because we can possibly want other things to be disabled, we'll just make it possible for us to send in any element we want. To do that, we'll pass in a new parameter of type action, to which I'll name action. Be sure to import its namespace. Then, between the two lines, call in action.invoke. This allows us to pass in any method call we want, and it will be called in between those two method lines. With that done, back to our DSInspector script, in our drawDialogGroupArea method, copy the draw property field line and swap it with DSInspectorUtility.drawDisableFields and pass in an empty action and paste a copied drawProperty field line. This field will now be drawn inside of the disabled group. When that's done, copy this line and do the same in our DrawDialogue area method. Saving and going back to Unity, our property fields shall now be disabled. We don't really need to disable our dialog container property because we don't really use pop-ups to select it but use the actual property field instead. There's only one thing left for us to do, and that's our warning box. So back to our DSInspector script, go to our StopDrawing method, and in here we'll simply add the warning box at the end. We can do this because we always show this warning message until we actually have a selected dialog. So before applying the modified properties, simply type in DSInspectorUtility.drawHelpBox. You need to select a dialog for this component to work properly at runtime. And then pass in messageType.warning as the second argument. Between the two help boxes, we'll be adding a space to separate them a bit, so type in DSInspectorUtility.drawSpace. I'll also make it so we can pass in the message type for the first help box in case we ever wanted to show a different icon. So add a new parameter of type messageType, which I'll name messageType, and default it to messageType.info. When that's done, simply pass it into the first drawHelpBox method. If we now save and go to Unity, our warning help box should be showing until we select the dialog. Our custom inspector is done. We can now select a starting dialog. There are a few optimizations that could be done if you want to dive deeper into the code. I'll be leaving two possible optimizations you could do. The reason for those optimizations is the OnInspectorGUI method, because it runs multiple times whenever we have our inspector opened. The first one will be to cache the names of the groups and the dialogues whenever we save the container scriptable object in our DSIOUtility script save method. This will be as simple as creating 3 lists of strings and add the names there just before we save the assets. This will be better because we wouldn't call the getNames methods at every redraw, which can become expensive if there are a lot of groups or dialogues. The second one will be our loadAsset method. I'm not entirely sure if Unity already caches something internally, but if it doesn't, we are then loading the asset at every redraw, which can be expensive as well. One way to fix this will be to cache in the loaded asset into a static dictionary or hash set in our DSIOUtility script, which we will need to clear once in a while to make sure it doesn't waste unnecessary memory. But I'll leave that up to you because as far as my usage of this dialog system went, I didn't feel it being laggish or slow, so for me it's fine as is. One small warning though, this inspector was not done with multiple object editing in mind, so do not add the canEditMultipleObjects attribute, as otherwise selecting multiple objects will update the values of a selected object to the values of another selected object. With that, our custom inspector is finished. I've said it before, but we are not going to be making a custom inspector using UI elements. The reason why is because when we use UI elements, we need to use the createInspectorGUI method. The good thing about this method is that it's only called once when we open the inspector. We can then use the registerValueChangeCallback method to set a callback and do something when a certain value is changed. However, the problem lies in our help boxes and in updating our existing elements. Because our method doesn't get called again, the UI won't be redrawn. Because of that, our help boxes won't be drawn if we update a value that will make them show up. Nor would our existing pop-ups and property fields update when we select a new container, for example. This can be easily fixed by separating the areas into different visual elements that we will save a reference to, and then remove the elements inside and redraw them again by calling our draw methods. However, for some reason, properties don't seem to redraw when we do this. This means that our only option will be to, instead of removing the UI, to just hide it, by updating the visual element visibility. The problem with this approach is that we will need to hold a reference to all of the pop-ups and property fields so that we could update them whenever we change something like the dialog container. This is because we wouldn't be redrawing them but updating them, which will be done in the register value change callback method. This means that anytime we updated the container, we would have to set their options and values again. This would also make it so we have the same logic in multiple places when we could instead just redraw them whenever we wanted, which would have our logic stay in one place only. Of course, we could have these references in our inspector script, but I still felt like what I was doing wasn't right, and I believe I just personally couldn't find how to get to redraw the property fields. So while I wasn't able to find a proper way to do it, or at least one that I think is proper, I do leave you with a possible way of doing it, which is referencing the elements and having the logic be in two places of the code. The only thing you need to keep in mind is, I believe, the way Popup works here compared to the immediate mode GUI Popup. In the immediate mode GUI Popup, it accepted strings as the options, hence why we had to get a list of the names of the dialogues. In UI elements popups though, we can just pass in the list of the actual class type. This means that we are able to get a selected element casted to the class right away. It does end up showing a bit of a weird option text instead, but it also allows you to customize that text by setting its format selected value callback, which updates what the selected element text looks like, and its format list item callback as well, which updates what the options list text looks like. You can also get the currently selected element of the popup using its value variable. Another thing you need to take note is that you don't need to return a visual element in the createInspectorGUI method, which basically is a main visual element that will hold all the other UI elements. You can think of it as the editor window root visual element. It also seems to not need the serialized object, update and ApplyModifiedProperties methods. And that's likely what you need to know if you want to try diving a bit deeper into using UI elements in the inspector. I do apologize that I wasn't able to find a way that I thought was at least appropriate using UI elements, and I'll leave you with the custom inspector using the immediate mode GUI system instead. Of course, this is likely the most used UI system for custom inspectors, so it's likely to still be useful for you. So, with that done, that finishes up our node-based dialog system tutorial series. I hope I was able to teach you at least the very basics of using the GraphView API with this series, and hopefully your basic node-based dialog system is also working. Just as a final tip, there is one element that might be useful for you if you want to add more options to the node, such as an audio clip to play when the dialog plays, and that's the object field element. This simply allows you to choose an asset of a certain type, which can be an audio clip or anything else. Of course, you will need to update your code to also be able to save this new element. You are free to update the system as you see fit or as you need for your game. A link to this project GitHub page shall now be available in the description of all videos as well, so if you ever need to see it again without watching the videos, feel free to do so there. If you did enjoy the tutorial series, please feel free to give your feedback on it in the overview video, so that people know if it's worth it or not to watch it, or just give any feedback in any specific video if the feedback is regarding that video theme. This also allows me to know what to improve in future tutorials, so don't feel shy to specify what you did not enjoy. If you'd like, subscribing will also help me out a lot. So, with our tutorial series done, I hope you've enjoyed it, and see you in the next one.